Hello everyone, so this is a second part of these checkpoint questions on separation techniques, or some books will call it purification techniques. In the first part of that short video, I've briefly talked about the checkpoint questions involving paper chromatography, as well as the associated techniques on thinking about whether a substance is pure or in this case impure, because it separates into two different components or two different dots that travel up the filter paper, what we call the chromatogram. Different distances travel. That's because they have different solubility, because there are different substances in that impure mixture. Okay, so in this tutorial video, I'll just quickly cover the other separation techniques that I would have taught you in the normal lesson time, but you should have by right have gone through it on your own. I'm just teaching you how to break down the information, okay, just in case you have problem with them. So first question, you have a blue solid soluble in water. So which method is used to obtain pure solid? So you want pure solid X from an aqueous solution. Aqueous mean in water, aqua. Okay, so aqueous means in water. You have a solution is a mixture. So it's a mixture of X and water. X dissolved in water. X is the solute, so water is the solvent. Solution is the mixture when you dissolve the solute in the solvent. So I just want the pure solid from the aqueous solution. I just need to remove the water. Okay, I just need to remove the water. So we talk about evaporation in the lesson, but none of this is evaporation. Crystallization involve evaporation, and then you let it to cool because you want to get a saturated solution. So you can look through your notes. Crystallization is the best method here because it will remove, you will get crystals which are solid. The solid X crystallize out as pure solid crystals, and you will still have a bit of the solution. So you need to filter off the crystals from the solution. We talked about this in the class earlier, or whenever you had the class with me. Question 2, we have melting points. Melting is the change of state. Okay, it's a change of state. Melting point is a temperature, so you need to be very careful of definition. This is from solid to liquid. A lot of students, a lot of you guys have actually had problems defining what are the exact changes of state. All right, so these are from your topic 1 syllabus. We have 4 impure sample. Okay, so pure sample or pure substances have fixed melting and boiling point. If you remember your heating curve will have temperature, and then it will have time, and then you will have that and that. So that bit there is, not the x-axis. The x-axis is time, but this represents solid. This represents solid going to liquid. This represents liquid. This represents liquid to gas, and this represents gas itself. So what happened there is we're talking about fixed boiling point. Boiling point is the temperature for that particular change of state, which is boiling, and that is melting point, which is the temperature for melting to happen. So when does it start to melt, and when does it finish melting? If it is the most pure, it doesn't say it's pure because pure substance have fixed melting and boiling point, only one value. Most pure, you see that none of these are exactly the same. However, this thing is the smallest difference. So they can ask you in a theory paper, this has the smallest difference, in temperature. So meaning to say 372 to 373 degrees Celsius is very small, whereas this to this is a difference of 6 degrees Celsius. This to this is difference of 7 degrees Celsius. This to this is around 9. It is not 9. What is this? 13 degree Celsius difference. Here the difference is only 1 degree Celsius difference. It's not exactly pure, but they're asking for most pure. Question 3, we have lead iodide. You will learn more about formulas in a couple of months' time. insoluble in water. Insoluble mean does not dissolve. So this thing does not dissolve in water. You do this plus this, the fact that it said aqueous, the reason why it said aqueous mean in water. And when you say in water, that means it is soluble. Okay, so when you see aqueous, that means that substance is soluble because it's dissolved in water. All right, to give you an aqueous solution. So soluble plus soluble give you insoluble. Okay, so this is soluble, and then it gives you insoluble. So how can you obtain the solid lead iodide, which is this one? Okay, from the 20 cN³ aqueous lead nitrate, which is this one, when added to that one. Soluble, you get insoluble. So our product is insoluble. We do not need to heat it because this is not crystallization. Okay, because this is insoluble in water. So I definitely need filtration because I'm removing an insoluble solid from something which is soluble. So definitely that one. What else do I need? So I know I need 4. This one does not have 4. So this is out. Needed to obtain. Okay, so you need to add this to this, right? So if you have that much aqueous lead nitrate, you also need to add in aqueous potassium iodide. So you definitely need a beaker for you to do the reaction in, because you do not do the reaction in a measuring cylinder, you do the reaction in a beaker or in a test tube. All right, so 1 is definitely required. So this one does not have 1, so D is out. So now we are left with 1, 2, 4 or 1, 4, 5. If you look at number 2, this is actually a mass balance. A mass balance, as from the name suggests, it measures mass. Okay, and you do not need to measure mass. You have a solution, so you need to measure volume. This is a measuring cylinder. So a measuring cylinder measures a volume of solution. Okay, so you do need number 5 because you have a solution and solution. And number 2 is definitely not required. A is not the answer because it has number 2 there. So C is the best answer there. All right, so read the question and break down the information. So in this next question 4, we are looking at obtaining a concentrated solution of ethanol from a dilute solution of ethanol dissolved in water. Okay, so out of all the options given, I can tell you that paper chromatography is out because they mix well together, and that is not how ethanol is separated from water in the real life. Okay, filtration is also out because they are soluble in each other. Ethanol is soluble in water, so you can't separate it by filtration. All right, so out of 2 other choices, crystallization and distillation. Distillation would be the most obvious choice because ethanol is a solid, it's not solid, it's a liquid at 25 degrees Celsius. Okay, you should know that ethanol is used in alcoholic drinks, and it obviously comes out as a liquid. We also use ethanol in hand sanitizers, so quite a big thing during in fact we are still in the middle of COVID pandemic, so people are still using hand sanitizers which require the use of ethanol as a solvent. Okay, so distillation is the way to go, and it doesn't crystallize out because your stuff is not a solid to begin with. All right, in hindsight, looking at the question itself, it said concentrated solution. It's quite a badly worded question, I suppose, because solution would actually means that it's a mixture and it's in water. And first glance, I would have thought just by evaporating off the ethanol will be all right. But between crystallization and distillation, crystallization does not make sense because ethanol is a liquid at 25 degrees Celsius. In fact, when we want to separate ethanol from water, we will use distillation, and that was what I show you in the lab. If you are one of the few classes who are lucky enough to see the setup in the lab. Okay. Next question, question 5. We want to separate salt and water. So salt is soluble in water. Okay, so you need to be careful there. We want to obtain both parts of the mixture. So first of all, filtration is out because salt is soluble in water. When you think about filtration, you can be thinking about salt, sand, and water. Then you can separate the salt and the sand from the water. okay, because the salt will be soluble in water, the sand is insoluble. Or you can just be separating sand and water because sand is insoluble in water. It doesn't work for salt. Distillation doesn't work as well because the salt is soluble in water, and when you try to distill it, you will just get the water coming out, but you will not get the salt because the salt has very high melting point. Water will come off, but there's no way of you obtaining the salt. In terms of evaporation and crystallization, remember this is evaporating to dryness and this is trying to get it from a saturated solution, definition of which is in your notes because they're also in the syllabus. All right. Evaporation means heat to dryness. Well, in the context of separation technique, you heat it to dryness. That means loss of the water. So you don't get both parts, you just get the solid, but you lost all the water and they want both parts, so we set it to crystallize and we will still have the water as the solution mixture and the salt that crystallize out, which we can then separate by filtration because then the crystal will be solid, the water will be solution, you can do filtration. All right. So this question number 6 from the checkpoint question. Solution X contains one or more of three substances. It contains one or more of three substances P, R, and S. You don't know whether it's just one substance, meaning it's pure, or it could be more than one substance, which means it's impure and a mixture. 2 chromatograms to compare X with each of the three substances. So meaning P versus Q versus, P, R, and S. Read the question carefully. So P, R, and S. So this is a pure P, this is a pure R, and this is a pure S. All right. So this is the results. In the solvent 1, it looks like this. Okay. So the starting line is there, but the solvent you use, the solvent must be below the starting line, which is drawn with pencil, which is graphite, and you must take out the chromatogram, you must take out the filter paper before the solvent goes all the way to the top, and you use a graphite pencil, okay, to make a marking at the end where the solvent stops until, and you will have the solvent front. Okay, this is called solvent front. Just now in the notes it was said that this is the ending line. It's actually called solvent front. The distance from the start line to the solvent front, so from there to there, that is the denominator to find out the RF value. Okay, so what do we have here? This is what is happening here. So you have 2 chromatograms, so they are the same X, but they are taken at 2 different times. You obviously allow these to go further, or they could be in different solvent. As you could see, X has moved further, P has moved further, but S hasn't moved further. So here S travel further than P. That's because S and R are more soluble in this solvent number 1. Okay, so they are different solvent. In this solvent 1, R and S are more soluble in solvent 1 compared to P. That's why they travel further in solvent 1. But in solvent 2, P and R travel further than S. That's because P and R are more soluble in solvent 2 compared to S, which is less soluble in solvent 2. That's why it doesn't travel as far up for the same given of time. So let's have a look at solvent 1 first. So we know that if they travel the same distance up, they have the same RF value. All right. So we know R and S are different substances, but by looking at just this chromatogram in solvent 1, it seems that they have the same RF value. So what does that tell you? R and S have the same RF in solvent 1. Does that mean R and S are the same? Not necessarily, because if you look at solvent 2, you will see that R and S have different RF in solvent 2. So it means that they are not the same substance, because if they are the same substance in a different solvent, they should have the same RF as well. They should move the same distance. But here you can tell that R is more soluble than S is solvent 2, because R has moved further than solvent than S in solvent 2 compared to solvent 1. So R and S are definitely different. But this question is not asking you on that. It's particularly asking you what does X contain. So X is this substance. So we can say that the RF value, we can see that they move at the same particular distance in this solvent 1. So X contains R or S, okay? X contains R or S. Does it mean it's both of them? You see, that's why it is there to confuse you if you just look at one thing. But you must also complete the information and see whether it makes sense or not, alright? So based on this, we said X has R and S, okay? That is the first information. What does this second information tells you? This second information tells you X has P and R, okay? But if X has P, then what they should have another spot there in solvent 1. So X does not have P, okay? It's just that it's a coincidence that P has the similar solubility as R, okay? In this solvent 2, that P also appears to have the same RF value. The same reason here is not that X contain S, because you can see here X does not contain S because they have different RF value. You see, X and S has different RF value, so it means that you have to refine your argument a little bit. Alright, so P is definitely incorrect, R is definitely correct, S is definitely incorrect based on looking and comparing these two information. So R is definitely correct. So what we can say is definitely X contain R only. S happens to have the same RF by coincidence. P happens to have the same RF, the retention factor, by coincidence of the solubility in the particular solvent. So take the two information together and hopefully you can break down these things and come up to the conclusion that it must be X containing component R only. Let's put it to practice with another question, question 7. So chromatography experiments are carried out on 4 substances, P, Q, R, and S. You use the same solvent in each experiment. So depending on the solubility of the different substances in each solvent, they are going to travel up the filter paper, the chromatogram, at different rate, and therefore they'll move different distance, okay? So here you can see P only give you 1 spot, same with Q, same with R, but S give you 2 spots. S give you 2 spots because S is a mixture, not just one substance. It has more than one substance mixed together. That's why when you do chromatography, they will separate out because the 2 substances have different solubility, okay? Different solubility, okay, in that particular solvent, and remember the question earlier which I circle or underline or scribble. That's why we read question and we interpret the information, and we will remember it better if we circle or underline or whatever, okay? So which statement is not correct? So you need to be very careful. I just said that S is a mixture, so this is a correct statement, okay? P and Q are pure substances, only 1 spot, okay? Only 1 spot in each chromatogram. So it means that there's only one particular substance in that particular chromatogram. So it's a pure substance because there's only 1 spot in the chromatogram. So you want correct, right? Correct statement. So this is a correct statement, but you want incorrect statement, sorry, okay? P and R are different substance. How we can see that this is the RF value for P and Q, and then this is the RF value, how much it has traveled. So that, and of course solvent front should be somewhere on the top, which you will label it at the solvent front because that is where the solvent move until, and you will take out the chromatogram before the solvent is allowed to reach to the very top of the filter paper. This is how far the spot has moved. You need to divide it by how far the solvent has moved, but you can see different distance that has been moved between that has been moved from here to here. Okay, I better redraw my arrow. Like that. So there are different substances. So A and B are not what we are looking for. R and S are pure substances. R has only one spot, so R is pure. That is true. S is not pure because S is a mixture. It has two substances that have different solubility in this particular solvent. There's the same solvent used in all experiments, and we know we can see two components there. So S is impure. This is incorrect. So we obtain our answer like that. S is a mixture of substances, as I told you earlier. I've covered question 7. And I've covered question 9, which is the last question in the checkpoint as well. So I'll just go through this as your final question in this particular checkpoint. So we have solubility of 4 solids given in the table. We have, so a student attempted means tried to separate mixture of these solids using the following method. You add it to a beaker of water and stir. Some of it dissolve, some of it are insoluble. You filter the mixture. So the thing that dissolve will be the filtrate. Filtrate in the syllabus is defined as the liquid that passes through a filter paper, right? So the filtrate will be the thing that dissolve that will pass through the filter paper. Q and R will be the residue. Residue is the substance that is left behind after evaporation to dryness, or is also the solid that's left behind on the filter paper after you do filtration. Okay, so you filter the mixture and you crystallize one of the solid from the filtrate. So it's P or S. Which one of the following could not be separated by this method? Meaning this method does not work at all. Okay, crystallize from the filtrate is P or S. So you can crystallize P, you can crystallize S, but you cannot do it for Q and R because Q and R are insoluble in water. So Q and R is definitely impossible, okay, because it said could not be separated. You cannot separate Q and R from this because they are both insoluble, and when you filter them, they're just both stuck as residue. Therefore, you can't crystallize it because they were insoluble in the solvent to begin with. Alright, as I mentioned, I've covered question 9 before, so this is the end of this short tutorial video, and I'll see you in the next video. If you got any questions, text me or email me or ask me if you see me in school, and yeah, good luck with your revision.